All right, so I'll be talking about the Bitcoin hash war. So just a brief overview. In November of last year, about in the middle of our, I guess just when we started the research project, we noticed that all of a sudden Bitcoin Cash dropped a lot in value, and another coin popped up called Bitcoin SV, and it was a result of what was effectively a hard fork in Bitcoin Cash, which happens to be a major issue because when a coin of that size forks, usually there's serious implications, and Bitcoin Cash was number 4 when it forked. So basically, long story short, there was a dispute within the community of Bitcoin Cash about how to proceed further, and they split into 2 different coins. And I'm going to go over what happened there. Okay, so first, before we can really start talking about what what the dispute in protocol was before they split, that caused them to split, we need to know what the goal of Bitcoin Cash was when they first split from Bitcoin. So this is Bitcoin Cash. It was forked from Bitcoin in August of 2017, and the reasoning for the fork was they felt that if Bitcoin needed to be a competitor to payment things like PayPal and Visa, it needed to be able to process more transactions in a short amount of time. Otherwise, it wouldn't be adopted in any way. So the goal was to increase the block size from 1 megabyte to 8 megabytes. And that was like their suggestion of how they were going to improve the speed of the transaction. However, the core development team of Bitcoin had a different idea in mind, and their idea was something they called SegWit, which I will talk about in the next slide. But basically, the team that would later become Bitcoin Cash felt that the SegWit protocol was not effective enough at really speeding up transaction speeds. So they decided to fork a coin, and they made a new chain, or they forked from the chain, made a new, and it's a continuation, obviously, but the new protocol had 8 times larger blocks, like I mentioned. So Bitcoin Improvement Protocol 141 is SegWit, or segregated witness. It's the idea is, how do you make it's a way of making Lightning transactions more secure, and therefore making it easier to conduct small transactions, speeding up the total number of transactions computed on the chain. So a Lightning transaction is where you basically have like small transactions back and forth stored somewhere on like a smaller chain, right? And they get packaged up together and then committed together after a while to the blockchain as like one larger block. And obviously there's security issues with that, because if you have if you're not fully on the blockchain when you're doing those smaller transactions, you can't necessarily ensure that the transactions are legitimate. So the best way to do that is the idea that the core development team for Bitcoin came up with was SegWit. And basically the idea is that it separates the signature, which is some value tied to the transaction, from the address it's coming from, and it hashes them all separately. So it keeps a record of like what transactions have happened, but it doesn't spend the time to compute all the addresses it went through. And as a result, it'll accumulate that, and then it'll hash it together at the end. So the hash speed increases, but you do not have to increase the block size, which is good, because then weaker nodes can still compete in the system, and which is the main reason they have suggested this in opposition to the Bitcoin Cash alternative, which was larger block size, which makes it so that larger blocking groups have an advantage when it comes to mining. And then, so there's another thing called Bitcoin Improvement Protocol 91. So obviously they're going to roll out this massive change to the protocol if they're introducing SegWit, and the idea is, how do they do it? So 91 was the protocol they used to vote on the process. And 91, it passed, but basically the first thing it suggested is how do they vote? Well, every miner would add a bit 4 to their hash if they wanted to support the implementation of SegWit. And as you can see, this tiny block of code, which doesn't include all of it, but this is the setup for, this is how they like set up the protocol. And it's not the actual implementation, but it's like the sort of like the constant requirements that were just being saved in. So you'll notice that it has a bit 4 set into the consensus. And then same thing, it's the vote started on June 1st, 2017. So you'll have a Unix time equivalent of June 1st, 2017. And the vote lasted until November 15th. So it's the same thing with the Unix time equivalent of that date being stored in there. So the next thing is that it wanted 80% of miners to support the change before they implemented the SegWit or before they agreed that they were going to do it. So you'll notice that the miner confirmation window is 336. So miner confirmation window, what that means is basically how many blocks in a row it's going to take for your, as like a sample to get your 80%. So in the next 336 blocks, if 80% vote, then it gets passed. And that's the 269 value you see here, which is the threshold, because 269 over 336 is roughly 80%. So yeah. And it was approved on July 3rd, so it took about 20 something days to 22 days to pass. And yeah, that's pretty straightforward. But I think it's interesting to point out that it's like a continuous window. So like they were letting people vote continuously until it changed it. But I think it definitely reached 100% support before the fork happened. And there's more to be read there, but let's skip it for now. So the Bitcoin, that's meant to say, okay, so now that we know what happened when BTC and Bitcoin forked, let's go to the next fork, which is when BSV forked from Bitcoin Cash, which was BCH. So what happened was, so by default, Bitcoin Cash forks twice a year, or was intended to fork twice a year, because it really only went on for 1 year before the fork happened. But they update the protocol, they change things up, make sure that they're keeping the code up to date with the modern, or the latest demands of the people using the chain. And there were two sort of camps that showed up when debating which protocol to implement in the next change, in the next fork, and ABC and SV. So the two groups were unable to come to a consensus in any way of form of like what protocol to take it. So they started what was called a hash war, where basically miners supporting SV start using one protocol, and miners supporting ABC use the other protocol. And the goal is to get Nakamoto consensus, which is basically the majority of the chain. Like if the majority of the chain is operating using one protocol, then that protocol is dominant, because the longest block on the chain will be like according to that protocol, will be constructed according to that protocol, and will have like that verification. So there was like a large fight for computing power, where they basically just dumped a bunch of money into making sure that as many people were mining their thing as possible, so they could beat out the other thing and just sort of like brute force it into like the future of Bitcoin Cash. So it was really not a hard fork per se, other than the fact that until like later on, at the start, it was just, they just started implementing different protocols and saw what happened. November 15th, Bitcoin Cash dropped from 425 to 289 for Bitcoin Cash, and Bitcoin SV for 96.50. And so Bitcoin Cash wasn't actually called Bitcoin Cash at that point. It was called Bitcoin ABC for like about a day, when where basically the markets and the exchanges couldn't decide who was going to win the hash war. So the Bitcoin Cash thing was just not assigned to any of the groups. But when it became obvious that Bitcoin ABC, which became Bitcoin Cash, is now Bitcoin Cash, because they won the hashing sort of competition where they had a larger market share, so they got the BCH ticker. Well, you'll notice that 289 plus 96 is less than 425, so quite a bit of value was lost in just 1 day, and actually had a negative effect on the market, because in that same week, you wouldn't, if you look at it, you'll notice that Bitcoin dropped about $1,500 that same week. So that's fun. And I think there was a little bit of I don't think many people expected this to happen because when Bitcoin Cash split from Bitcoin, the value of both coins combined was actually higher than Bitcoin before it forked. So I don't think they were expecting this to happen, but it's clearly like a notable negative effect. And furthermore, there's even more money lost because when they were competing when they were doing the hash war, they were like basically pouring a bunch of electricity into making sure they had as many nodes mining as possible. So that sort of exacerbated the effects. But again, here's the Bitcoin Cash market from like 2014. So you'll notice it starts dropping once people realize it's going to split, and then even more. That's fun. And yeah, so it started, like I said before, it forked, it was number 4, and that's why it was a big deal. This is from like yesterday. So Bitcoin Cash is number 5 and Bitcoin SV is number 10. So it definitely was a net loss. Anyway, so what specifically was Bitcoin ABC advocating for in their sort of protocol and why did it work out? So, well, they're generally against changing the protocol too much. They thought it was pretty solid, and the only thing they really wanted to say is like their ABC, which is adjustable block size cap, and they didn't really want to change it, but they said, okay, once it gets to the point where it's not good enough, we'll change it, but for now we'll be fine. And they decided to keep it at 32 MB, which is kind of strange because now you have this misnomer where the group that's advocating against changing the block size has adjustable block size cap in their name. But anyway, they also wanted to introduce smart contracts because they felt like that was a new sort of direction that would bring in more people to use Bitcoin Cash. And it's supported by these two big names in crypto. So Roger Ver is like a famous sort of investor in the space, and Wu Jihan runs Bitmain, I want to say, which is like a application-specific integrated circuit company, basically the company that makes all those computers that are designed specifically for mining Bitcoins, and they're, I think, the largest one, if I remember correctly. Anyway, they were ahead in the hash war, and they had 66% block power on the 16th, the day after the fork, which means that basically 2/3 of the nodes of the old Bitcoin Cash were running the ABC protocol, which is why the exchanges gave the ticker over to them. I think one thing I noticed when looking over the code for Bitcoin, the Bitcoin ABC protocol, that I felt was interesting was that on November 28th, they released a new version of their node where they introduced this thing called deep reorg protection via finalized blocks. And well, reorganization is when there's like an issue and you have, when the chain sort of like doesn't work and you get two large chains that interfere with each other and you can't decide which one to trust, right? So, and as a result, one of them has to be invalidated, otherwise the chain doesn't work out. So some of the transactions actually just get completely negated, and that is a big hit to the whole immutability part of the blockchain, which is a big part of its appeal. So I know for sure that other chains have this, but they specifically did like a pretty major upgrade to their current protection in this patch. And yeah, their goal is to make sure that reorganization doesn't happen because blocks older than by default 10 blocks deep are automatically finalized onto the chain no matter what, so they can't be reorged unless there's like a very heavy manual override. So let's look at some code about how they did this. So this is a function that they used to finalize the block, and you can ignore the numbers and the plus signs on the left. That's just from that's just for visual stuff from GitHub. It's not actually part of the code. But you'll notice that, I guess I'll just walk through it. So there's the assert lock held, which basically means that before you try to like do any of this finalization chain, you want to make sure that the chain is not being changed so that it's not moving along. Oh, okay. The chain's not being moved along so it doesn't mess up the sort of finalization process. And then next you check if the P index is going to refer to the current block in the chain. So and you're going to check to see if it's invalid. And then if it does, then you're going to just create some massive error. So the goal of this is that how do you know which block you're finalizing? Well, you put an index value you have an index value assigned to every block in the chain, and you just use that to find the correct block. But if the index is invalid, then obviously you know that you shouldn't try to do anything with that block because there's going to be some error that happens. And you'll notice that it returns, there's a return here, so which means that it'll actually, once it returns the error, it'll actually stop, so it won't execute any of this part. So, and then the same thing happens here, where you have the same sort of idea. You want to make sure that the index is finalized, and then that if it's going to be finalized, then it's on the same fork as the current index you're at. So this index, I believe, is calculated from the, so the prior index to be finalized is basically calculated from a while back, from like a previous section, and then they decide to see if the current index that you're at is on the same fork as the one that's like 10 deep by default before you try to finalize it, and that's just to make sure that you're not finalizing something that's on a different chain than the current fork. And lastly, right here, you're setting the current index to the old final. So this is why it'll like loop around the next time you do it. The one that you currently finalized, the one that you were checking the first time becomes the one that you're going to finalize the next time. And then the next one comes in the chain. So you gotta that, and then obviously once you reach this part, you just return true because it succeeded. And then here's a bit more on how that happens. So you get the n height, which is the current stack, the height of the chain, the current point of the chain. And then from there, you also use, once you get the current height of the chain, you want to calculate the 10 blocks deep. So use the depth math, default max reorg depth, but that's the backup. If they specified a max reorg depth when they started the node using this, then I'll use that value instead. And I'll just calculate which block they want to finalize, how deep in the chain they want to go and finalize. And then the same thing. So you get the index to finalize by get ancestor, and that's the same thing I was talking about earlier, where it gets the previous block, finalizes it, and then makes itself the previous block, sort of, so that when the next thing comes along, it'll be easy to, it'll just like flow into it. So, and then next is, it'll try to do this, and if it gets an error, you notice that it will fail. Otherwise, it won't. So I think if we go back, so you'll notice this function is called finalize block internal at the top, and it's being mentioned here. So once this line executes, it's going to finalize, and if it fails, then it'll return the other error, but if it succeeds, it'll just continue. So that's that. And then next on to Bitcoin SV, which is the new one. Here's their logo, the very humbly named SV for Satoshi Vision. Yeah, I think they decided that was a bit excessive, so they did end up changing it to this eventually. But anyway, Bitcoin SV stands for Satoshi Vision. And their big idea is to restore the Satoshi protocol, whatever that means. But they don't specify very much, but I think the general concept is that they're going to make Bitcoin Cash more like Bitcoin, like the original Bitcoin before SegWit was implemented, which is like kind of convoluted, but whatever. But the one thing they will change is that they'll increase the block size to 128 megabytes, which seems kind of in the opposite direction of what they were trying to do, because Satoshi's original vision is like everyone has this peer-to-peer cash system that they're paying, and it's super decentralized. But if the block size is that large, then it definitely favors large mining corporations or organizations. So that's kind of interesting. And they're so-called, they're defining their Satoshi vision as making a stable sort of platform. Their main goal seems to be to just revert it and then just not touch it as much as possible. And then they want to scale it again. Same thing. They also want to implement smart contracts. So it looks like that seems to be the new way to go if you want to get more people on your chain. And security, payment experience, just the usual. Make sure that people are actually people trust your chain enough to use it to pay people. And Craig Wright is the person who's sort of spearheading the Bitcoin SV thing. Anyway, so continued. So like I mentioned, the ABC was awarded the BCH ticker after BSV fell behind in the hash war, and that sort of like finalized the fork. I tried to find some code to walk through, but they basically their current version that they are using is on GitHub is still 0.1.0, like from October 15th before the fork. And that's obviously it's still different from the original Bitcoin Cash because they wanted to make sure it was out before the fork happened. But even then, the fact that they haven't touched it since October 15th is kind of questionable. But they did they did mention that their goal is not to change it as much, to not change the original Bitcoin protocol as much as possible. So they just restored it and left it like that. But yeah, they haven't really touched it. So it's hard to say if they're just completely abandoning ship or what's really going on. But another interesting thing I found is that there was Bitcoin Cash, the ABC version, implemented a reorg protection on the 20th of November 2018, on the same day that Bitcoin SV had a reorg issue. So I don't know what's going on there. Some people might say it was an attack that was deliberately caused to create an issue, but no one has really said that. I've really confirmed it, and regardless, it's hard to really put it's hard to really assign value to much of these because they're like pretty large. The backing behind both of these chains is pretty large, and they have like a lot of influence specifically over like the Bitcoin, like the crypto community in general. So all these like news sites could probably have like a very noticeable bias when they're reporting on these issues. So there's not much I can conclude. But anyway, here are my sources.
Great.